next one is priority queue. So priority queue, which is a type of queue that arranges elements based on their priority values. Every item has a priority associated with this. For example, the real-time example, we can consider the employees present in an organization. So if the higher level employee means the order from those employees must be considered by the lower level employees. So that is the main priority which is given to that role, that given to that position in the organization. So, and at the same time, if any of the issues occurred in the lower level employees means we must need to make acknowledgement to the higher level people, then only they will tell to that the original persons of that organization. So original persons in the sense the owner of that organization, because a person in the lower level employee cannot directly interact with those persons. So those kind of priority, because the owner will give priority to the higher level people only, not to the lower level people. So the words came from that lower level people, which is not good having the higher priority comparing to the higher level people. So that kind of thing is called as the priority. Priority in the sense which one is having the most value, that should be treated first. So for example, the priority queue, which is a type of data structure. Here also we are inserting, deleting, and what is a value. In this thing we can consider the queue as a heap, as a tree data structure. If you are saying the min heap, in the sense the minimum value must be present in the parent. Max heap, in the sense the maximum value of present in the parent, um, comparing to their children. So all those lower level nodes in the heap must be lower comparing to the root node present in the next level, that is a higher level, that is max heap. In the similar way, min heap, in the sense the values present in a particular level, all those lower level nodes must be greater than that root, that node present in that any particular level. So these kind of, that is a priority we are giving. So priority queue is ascending or descending. How we are implementing this priority queue is using arrays, linked list, or binary search tree, and heap data structure. But we are focusing on the heap only. So tree data structure only. N nodes, in the sense that is of height log n. So the highest or lowest priority element can be removed or inserted. Two types, min heap and the max heap. Min heap, in the sense at the root node must be less than or equal among the keys present in all of its children. This is the min heap. And the insertion in the min heap, in the sense if new element is added, the element are ordered in the level order traversal only. In that level order traversal, we need to have, so the next available position is inserted with, filled with a new node, but we need to verify the heap property. If the new node is greater than, means we need to swap which one is the minimum node with the next level. So this process is repeated until the heap property is maintained. So this is the insertion. So for example, if you are inserting 1, means that is inserted in the 10 left child of 10, but the property is violated, we need to make change this 10 with that 1. So 10 is under the place of 1 and 1 is replaced to that in the 10th position. But here also the heap property is not at all satisfied, because 1 is smaller than the root node. So once again we are swapping this 1 with 2. So 1 is the root node, right child of 1 is 2, and the left child of 2 is 10. This is the final heap. Deletion, in the sense minimum element only deleted, so the root is deleted. After the deletion of root, the last element in the heap is replaced with that root. Then verify the heap property. If it is not satisfied, means replace with the lower level of child. This process repeats until all the nodes satisfying the heap property. For example, here 13 is deleted, 100 is replaced with that 13, but 100 is not minimum, so comparing to 16 and 31, 16 is minimum, 16 is replaced there, and 100 is in the place of 16. But once again, that 100 is not minimum. Comparing to 41 and 51, 41 is minimum. So 100 is in the place of 41 and 41 in the place of 100. This is the final heap structure. And max heap in the sense, similarly min heap, max heap in the sense, the root must have the highest value. So the complexity is for the heapify and the build heapify operations log n, because we need to traversal all the nodes in the tree. For the build heap, time complexity n, because once the elements are inserted, if it is not in the order means we need to travel from the root, that's why n. For the insertion is log n, for the deletion is also log n, for the peak, which is only one operation, O of n, and exact minimum is the log n. And the space complexity is also similar to, but the build heap is log n and insert node is O of n. All the remaining things are same with the time complexity. So representation is, here the vector is used to represent the element, and size and capacity. Capacity is maximum number of element to be inserted. Binary heap, in the binary heap in the sense, index and the left and right child. Left child is 2 into I plus 1, right child is 2 into I plus 2. For the heapify, if I plus 1 is inserted, we need to travel back to the previous level. For the heapify operation, the same as if the violation happened means, we need to replace with the left or right child. This process repeats until everything is completed. And the insertion in the sense, empty 1 is inserted. This is the representation, because 10 is higher, so which is replaced with the 2, then 4 is replaced, then 8 is replaced. For the insertion, which is inserted in the empty position, so the minus 1 is which is minimum, those things are replaced and placed in the root. Extract min in the sense, the 2 is extracted and 10 is replaced. 10 and now goes with the minimum one, that is the extract. So 10 compared with the 3, then 6 is replaced with the 10. So this is the priority queue. In the priority queue, max and min heap we have seen how to insert, how to heapify, how to delete, and how to pick the element with that space and the time complexity. Min heap in the sense, minimum value is maintained. Max heap in the sense, maximum value is maintained in the parent level.